Hello. This is the next re-recorded solution video for my puzzle, the Cheez-It Ring. So I just finished recording the Cheesy Adventure one a little bit ago. Figure we'll just roll right into this one. So the description says, most of us are familiar with the Fistamifel ring, but it seems that very few are aware of the Cheez-It Ring, which I discovered in April 2025 after taking a few weirdly placed bites out of my Cheez-Its. As you can see, I got pretty hungry. I just kind of ate the middle out of this one, I ate the corner of some of the others. So I'm not really sure the world is ready to handle its salty power, but I figured I felt compelled to share it with everyone. And so we'll notice that in this case, I introduced a second version here that does not have the Cheez-It graphics on it, just because it is a little bit distracting. But I'm going to solve it with the Cheez-Its for the sake of visuals here. A little more entertaining. Just makes some of the pencil marking a little bit hard to see, but you know the humor here is, I think, worth it, so you can follow along on the other version if you want. The links are identical otherwise, like the solutions are the same. So, for this we have normal Sudoku rules apply, 1 to 9 everywhere. Dynamic fog, so once we start placing things in the fog, we will start to clear the fog away. Consecutive pairs, digits separated by a white dot must be consecutive. At one point in the draft of the rules, I had it in parentheses say that this was the salt, because clearly that's what I was going for here. That was a very intentional design choice. That it was the Cheez-Its with a lot of white dots for salt. Killer cages, digits in the dotted line cages must sum to the number in the top left corner of the cage. So these 4 sum to 24, these 3 sum to 12, etc. From whispers, adjacent digits on a green line must have a difference of at least 5. So that's this. And then X pairs, there's no X's visible, but if we see an X appearing between cells, it would look something like that. Then those 2 digits must sum to 10. Finally, arrows, digits on an arrow must sum to the digit placed in that arrow circle. So if we determine there was an arrow like that actually wouldn't work. If we had it like 3 like that, then these 3 cells, whatever they sum to, that number would go inside the circle. And that's it for the rules. You'll notice if you did Cheesy Adventure before this, that this does not have the cloned region aspect. One, because clearly this one's a different size on the center. That was a terrible selection. These 4 little areas are different. And then these are not the same as each other, just by Sudoku logic and all that. So, with all that in mind, we can get started. The title and the description on Logic Masters reference the Fistamifel ring. That is not relevant for the solve at all. That's like a hint 0, I'll say. You do not need to know about that in order to progress here. It is helpful, in some sense. You don't need to use it logically, but it is helpful to be aware of, I guess, the patterns that presents into the grid. But you do not actually need it logically, so I'm not going to prove it here, just because you don't need it. There are a bazillion videos out there that explain the Fistamifel ring. I find one of the more good ways of explaining it is if you go to the Number File YouTube channel. Simon from Cracking the Cryptic did a video on there where he demonstrates it. Yeah, so the actual hint number 1 is the cages in columns 3 and 7 force the digits in those cages to be fairly restricted in boxes 1 and 9. At least 2 of their digits must appear on the small Cheez-Its. So, let's first look at these cages. This is similar to the beginning of Cheesy Adventure, where we had 4 cell cages summing to 11 and 29. Here, similar, except we have 10 and 30. So we can say straight up say 1, 2, 3, 4 in the 10 cage, and 9, 8, 7, 6 in the 30 cage. We also know, because of the double white dots, that this is going to be, one of them will be 1, 2, the other will be 3, 4. And here, the other will be 6, 7, the last will be 8, 9. We can't just have one of them be 7, 8 in the center, because then the other would have to be, say, 6, 9, and that wouldn't be consecutive. So, that was the first kind of portion of the hint. It's drawing attention to the cages in columns 3 and 7. And it then references boxes 1 and 9, in that these digits are restricted there. So, for example, these 4 digits, where do they go in the top left box here? Well, they certainly don't go there. And there's 4 of them. So, 2 of them might go here. In fact, they kind of have to. 2 of them will go here, potentially. We could actually have all 4 of them up here, but at least 2 of them could potentially go here, even in the minimum case. And if that is the case, then we know for sure 2 of them will be up here. It could be all 4 of them, but at least 2 of them will be here. And that puts a lot of pressure onto what this cage could actually total up to be, because it's 24 with 2 consecutive sets of numbers. Now, normally I would say that this would be a case where you could do this intuitively in your brain if you like the mental math. I personally say don't bother. I say use a little website I like to use that I will link in the description here, which is this, which gives you all of the combinations of cages that are possible for a given total. That, or, make sure I have the right version open, that, or just use the cage calculator within Sudoku Pad. And so from there, we could just immediately rule out all of the cases here that don't involve two different sets of consecutive numbers. So it's not 1689, it's not 2589, it's not 2679. Could be that. It's not 3579, it's not 3678, it's not 4569. It could be 4578. So we've already ruled it down to two options, both of which involve having a 4 and an 8 in it. So we can at least initially maybe pencil mark that. 4 and 8. And now we'll have symmetrical logic going on down the bottom right with the 6, 7, 8, 9 cage, having a 16 cage with two consecutive sets of numbers summing. That we're going to need two consecutive options here. 1, 2, 4, 9 doesn't work. 1, 2, 5, 8 is not. 1, 3 doesn't work. 1, 3, 5, 7 doesn't. 1, 4, 2, 3, 4, 7 doesn't work. And again, we have two options. But we do need to now think about the fact that, like we just pointed out, two of the digits in these cages will have to appear here. So we have 6, 7, 8, 9. Of the two options we have here, only one of them involves using two of those numbers, and that's 1, 2, 6, 7. If we did 2, 3, 5, 6, we would have to cram the 7, 8, 9 into just these two cells, and that doesn't work. So this is definitively 1, 2, 6, 7. And again, we could do the same logic up here. 1, 2, 3, 4. Two of those have to be on the cage that we choose here. So it's going to have to be 3, 4, 8, 9. Now this is going to allow us to do a ton of additional pencil marking, even though it might not seem it right away. We can do almost all of the entire perimeter of the four corner boxes. And that is what hint 2 kind of nudges towards. Hint 2 says, further pencil marking of the corner boxes will make it clear how heavily restricted the row 3 and 7 cages are. So that's referring to this cage and that cage. So once we do some pencil marking, it'll be clear kind of what could possibly go in these. So the pencil marking we need to do is we have 1, 2, 3, 4 locked up here, and we have 3, 4 there. So 1 and 2 in this box must go there. Similar down here, 6, 7, 8, 9. We haven't used 8, 9 over here, so 8, 9 goes over there. That now gives us a triple here, because we now know we're using up 1, 2, 6, 7, 8, 9. So that means this must be 3, 4, 5 triple, which now allows us to go up here and put the remaining parts of the column 1, 2. Similar over here, we've used up 1, 2, 3, 4, 8, 9, so we need 5, 6, 7 there. And that leaves us with 8, 9 left over here. And now we can think about the row 3 and 7 cages, because we have this pattern going on now, where there's a couple numbers this cannot include. We have 8, 9 in the row over here, so the 17 cage cannot include an 8 or a 9. The only way to make 17 in 3 cells without an 8 or a 9 is if we have it be 4, 6, 7. So that being 4, 6, 7 means this is no longer 4. That's a 3. Which means this is at least an 8. It also means 3 comes out from here. And because we know the way these dots are going to work, that takes out 4 from here by extension. 4 comes out from there. 3 comes out from here. So we now know the lower dot is the 1, 2 dot. The upper one is 3, 4. Continuing our pencil marking, we could say the remaining parts of this row are 1, 2, and 5. Which means this is 3, 4, 6, 7. Now once again, we can do similar logic up here. Slightly different the way we'll have to use this, but we could do the same idea of this 12 cage cannot have a 1 or a 2 in it. And the only way to do that is if we have the cage be 3, 4, 5. Now in order to resolve this, we now need to use the white dot here. This can no longer be a 7. Could be a 6, it could be a 5. So, over here, well actually it can't be a 5 because we have 3, 4, 5 there. So that is now 6, that's 5. This takes out 6 from there, 7 from there. 6 comes out from there. And now the remaining portion of this row is a 7, 8, 9 there, with 3, 4, 5, 6 in the corner. And so this is sort of the power of the sort of ring pattern, that we get all these digits worked out, and it allows us to completely pencil mark all of these corner boxes of the grid, even though we don't quite have it worked out exactly what they are yet. In order to clear fog, we have one thing left that I missed down here, which is that this is a white dot in the 17 cage. 4 cannot go on that, 4 must go there. And that now clears our fog to the next stage of the puzzle. This is one of my favorite deductions in the whole puzzle, but it's definitely not immediately obvious. Before we get to that, there's another classic Sudoku thing over here. We have an 8-9 pair, so that's a 7. And 7 coming out from here means 6 comes out from there. We know this is the 8-9 white dot, and that's the 6-7 white dot. That also takes out 7 from here, 6 from there. So we're making good progress. There's not a whole lot more else we can do in the corners. So we now need to draw attention to the center of the grid, because we got these white dots revealed. This is a very salty Cheez-It in the middle, and also a portion of a green line down here. So this is hint 3. Hint 3 says, the white dot sequence in column 5 is very hard to make exist without breaking cells on the ring. Row 5, column 5 can only be 3 digits, and one of those digits has nowhere else in the column that it can go. So that's a lot of info at once, but take it down one bit at a time. The white dot sequence is very hard to make exist without breaking cells on the ring. So what does that mean? Well, if we try to put in a potential sequence of numbers here, this is 3 sequential numbers in a row. So this could potentially be a 1, 2, 3, for example. And that seems like it would be fine. If we now move it up to 2, 3, 4, we immediately hit a problem because 2, 3, 4 breaks this cell. We cannot have 3 or 4 in that now. If we snake this up and go 3, 4, 5, we still have the same problem of 3 and 4 being up here. 4, 5, 6 works fine. But if we then move up to 5, 6, 7, we now start to have the similar kind of problem on the bottom portion here. 5, 6, 7 doesn't work, and 6, 7, 8 doesn't work. 7, 8, 9 does work. And so what that leaves us with is we have this center bit is either going to be 1, 2, 3, 4, 5, 6, or 7, 8, 9 in that order. So that leaves us with 3 sequences, with the middle portion will either be a 2, 5, or an 8, depending on the way that each sequence breaks out. But we've at least limited that down. So this is 1, 3, 4, 6, 7, 9. This looks a bit silly to pencil mark, but we have that sort of deduction placed there. In order to have this actually go anywhere, though, we now need to think about the final part of that clue, which points out that one of those digits has nowhere else in the column that it can go. So that is where the German Whisper line comes in down here. So the effect that this German Whisper has actually has pretty much nothing to do with what's going on down here yet, although we will see more of it in a bit. The reason this is here is because you cannot put 5 onto a green line. That's just part of the logic of that. You can't have digits be 5 away from a 5. So 5 can't go in those 2 spots. 5 can't go there, 5 can't go there, 5 can't go there. 5 can't go in any of these spots because we have a 5 in this box. So 5 in this column has to go there. And that tells us that this is a 4, 5, 6 in the center of the grid. And that reveals an additional white dot up here. This is an even more salty Cheez-It than expected. And this one is also another neat little tiny deduction. It's not as obvious, but we have to now ask, well, which direction is this sequence going? This could be starting at 6, 5, 4, 3, or it could be 4, 5, 6, 7. Well, if we went 6, 5, 4, 3, we would end up with 4 here, 3 here. And that, once again, just like before, breaks a portion of the ring here. So this is not a 4. That must be 6, meaning this sequence is ascending from 4, 5, 6, 7, get another dot, 8, get another dot, and we get a 9. And that now reveals a bunch of stuff. So we got the remaining portion of this line here, and we also get the total for this cage, which is now revealed. But we could do some cleaning up of classic Sudoku. We have a 7 and a 6 there, 3 and a 4 there, 8 here, 9 there, 8 here, 9, 8, 9. And then this now must be a 1, 2, 3 here, with the 2 in the center, 1 and 3 like that. So now we can draw our attention down to the lower part of the grid. Again, we have our green line here. We can maybe pencil mark that in, and we could say that we don't know if this is low or high, but if we put in all the options, we see that it cannot be 4, 6, 7, 8, 9. So this must be a low digit. That must now be high, can't be 6 or 7. This must be low, cannot be 3 or 4. The next thing we can look at is the cage over here. We didn't know what order these numbers would be in, but we know an 11 cage, the only way to make 11 out of any of these 4 digits is 4 and 7. So that tells us this is a 4, 7, that's a 3, 6. That does some work up here. 4 comes out from here, which takes out 3 from there. And then that's actually all we can do up there for now. So the next thing we now need to look at is finish pencil marking this box. It might seem a little silly at first, but it'll be easier to see the next step if we do that. So what this could be is, it could be almost anything. It could be 2, 4, 6, 7, and it can't be 1 or 3 because of this up here. 2, 4, 6, 7 comes out, 1 and 3 comes out. And this could just be 1, 2, or 3. So we end up with this sort of 1, 2, 3 triple and a 5, 8, 9 triple here. The important part, though, is actually that the row has an 8, 9 pair, meaning this is definitely not an 8 or a 9. That must be a 5. That's going to sort out, I believe, most of this. That's 7, that's 4. That now has to be 3 with 6 there. 3 comes out from here, and it gives us a 1, 2 pair, so that now has to be 3. 6 comes out from here, 7 comes out from here, so now we know the top dot is a 1, 2. So the bottom one is 6, 7. That now gives us the cage total for the top right of the grid. 6 comes out from there first. So once again, we can kind of look at the total here. Again, I'm using the cage calculator because it's easier. We have 3, 4, 5, 6. The only way to sum to 14 and 3 numbers there is with exactly 3, 5, and 6. Meaning 4 does not go in this cage, 4 goes there. 4 being here now tells us the order of these dots, because we have 8, 9 looking there. So 8, 9 is not on the top. That must be 3 and 4 like that. 3 in that row now resolves this cage. Very satisfying how this bounces back and forth. And then that now also bounces back and gives us the 7 and the 5 in that order. And it reveals our 1 and I believe only X clue in the puzzle. We have an X on this side here, so we have a 1 or a 2 here, meaning this is an 8 or a 9 in order to sum to that. Now underneath it is a white dot, so to be consecutive with that, there must be a 7, 8, or a 9. And there's sort of 2 ways we can see this deduction. You can either look at this and you can say there must be an 8 in between them, or you could recognize that we have an 8, 9 pair in the column. Either way, it actually leads us to the same thing of having a 7 here, with an 8 there, 2 here. Which also then gives us a 1 there, 9 here, 8 there, 9 and 8 on the bottom. And it reveals a couple of arrows that we don't exactly see what they're doing, but we'll come back to those in a second, because we could probably do some work here first. Here we need a 1, 2, 6, 9. And that's a 1, 9, 2, 6. And 2, 1. So we are very nearly there. The arrows are basically just disambiguation at the end. I find arrows are actually pretty good at disambiguating grids at the end, because it's usually pretty easy to find a spot where arrows can go where they're not useful early on, but they are useful at the end. So let's look at this one first, maybe, because we can immediately see where this is going. Arrows are generally not allowed to branch unless they say they can branch. There's technically no rule against it, but we really don't know for sure. But we do know for sure that it's at least doing this. You know, maybe it also branches up here, but chances are probably not, because we're all in the same box. So let's just think of what this could even be. Can't be 3, 4, 6, 7, 8, or 9, and the sure as hell is not 1 or 2, because that's way too small of a total. So that is a 5. And that means this is either 1 and 4, or 2 and 3. The right portion cannot be either 2 or 3, so neither can the other. That gives us 1 and 4. It gives 3 and 4 over here. And then gives us 2 and 3. That now fixes the middle of the Cheez-It, as well as the 2 and the 1 over here. Now we have our other remaining arrow. So what could this be? Well, this row needs a 5 and an 8. Those seem equally possible at this point. This row needs a 4, 6, and a 7. That gives us 6, 7 like that. Oh, no, not 6, 7. That's... what did I miss? Oh, 4 is already in the row. So we need 6, 7, and 9. That's what it was. Then down here, we need 1, 2, 6, or 7. It's a little too open. What we can say is that there's certainly not a 9 in the middle of this arrow. So that is a 6. And now in order for this to sum to anything bigger than that, that has to be 8 with a 2 underneath the 6. And that is now going to resolve the rest of the grid. 7 and 6. And the message says at the end, big Cheez-Its are better than original Cheez-Its. I will die on this hill. I still stand by that now. Almost a year later. I will always take a big Cheez-It over the originals. Mostly because I just find they're saltier. And I just like salt. So that is the end of this puzzle. The reason I included the other version here without the graphics is especially towards the end here with all these pencil marks and numbers everywhere, it could be really hard to even remember that, you know, for example, you have the 1, 2 down here. I find that really kind of gets disguised a little bit by all the graphics. And so you can solve whichever version you wish to solve, but yeah, so that is the end of this one. Thank you for watching.